or at least hosting from time to time. I'm going to talk about architecture, so if you came to see code, then it's going to be really boring for you. I don't mind if we have time at the end. I don't mind firing up Visual Studio and showing you a little bit of how this code actually looks like, but I'm not sure it's going to satisfy your hunger for real code demos and stuff. The title of the talk. First of all, this is the first time I'm giving this talk, so I apologize sincerely on how bad it's going to go. But you know, I'm trying. The title of the talk is trying to talk about two concepts. One is how we decompose our domain, and the other one, why is it a problem? Why UpdateUser is a problem? Does anybody think UpdateUser is a great method? What? No, no one. Great.
What, do you mean like
So I my work cut out, right?
like a CRUD update? Is that what
Yeah,
you mean, Sean?
yeah, the kind of crude updates. Yeah. We all, at least the older one among us that built monoliths for a living for a long, long time. That's what we learned, right? We build crude, and then the crude operations are like, you know, create, update, insert, delete, and this crude operation is a generic, well undefined method that does everything, right? And it does everything. Initially, it's really clean and nice because it's, you know, we don't have a lot of use cases in our business. But later, when things get really, really interesting and the code is V2 and V3 and V4, that becomes like a one monster of a method that has so many, you know, hundreds of code paths, loads of if-else's. Yeah, know the drill? Been there? Done that?
Yeah.
So the UpdateUser means nothing to me. Is this thing that I'm trying to say is like, what are you trying to do? This UpdateUser thing has no meaning, and we are allowing this to build a big ball of mud. Yeah? Does that make sense?
Yeah.
So I'm hoping that in the context of and decomposing your monolith, I hope that makes sense. Yeah. So how do we logically take a domain and instead of building it as a monolith, all bound together and end up with a big ball of mud, we go the kind of microservice, service-oriented architecture way, where we are building smaller bits and making all that work together. Okay, so that's the concept. So when we build a traditional monolith, the traditional design pattern is that we look at the domain, we ask the business owners, the business experts, what's going on. They say, oh, we have a user and we have an account and we have the bank accounts and we have, you know, whatever shop products and we have prices and all that, and you figure out all those things and you build a beautiful data model, right? That, you know, we have every table has all its properties, and those properties belong in that entity. Yeah, that user, that entity has an identifier, and everything inside it is our fields. That's our data, and we add all them together, and we start kind of to create all the relationships between them, right? So if I create an order, I need to create an order line. I need to add a product to it. I need to make sure I have a price, and so on and so forth. Yeah, kind of single, and we basically build something like that, right? Now this is a simplified thing that I put together in 2 minutes. So ignore all the SQL mistakes and all the why are you calling this, yeah, that. But basically, you know, we have like a user, we have a customer, we have an account, then we have orders, we have line items for the and that goes to the product. We have a payment for this order, right? And then we have the order status and update status and so on and so on. Yeah. Questions about that? Anything that anybody want to say that that's not what we used to do at least? Is that all right?
What were we thinking?
What were we thinking? The main problem here is these little relationships. Yeah. They introduce coupling, and they then bring us to to what happens after we add the layers on top, right? We put the data layer on top of that, right? We need the CRUD operations. We need, of course, some kind of framework, because doing SQL on such a large dependency graph is really, really hard. And if you want to read and write and update and do ACID updates, yeah, you want to do like get a data set. Remember data sets? Get the data sets and create an update and make sure that that update is the right version of the data. Yeah, sounds familiar? Mm-hmm. So these things are where we start introducing the complexity. On top of that, we build the business logic, right? And now the business logic is another layer of problems, yeah? So we hide away all the data problems, and now we put this business logic. Now the business logic has to get some data, do something, store some data, read some data, do that all over again and again and again. And as the data, the business logic grows, we end up with more and more stuff in our code that look clean but are very, very, very heavy. And then we add the UI on top of it, which is the final nail in the coffin, right? The UI wants to do totally different things to what your data model wants to do and what your business logic wants to do. We squeeze it in, and don't forget the kitchen sink, right? We now introduce all the lovely frameworks and this UI that has all these amazing behaviors, but it needs to do all kind of funky stuff. So then it becomes this something like that. Big, hefty ball of mud where the dependency graph looks really, really incomprehensible. And this is like, this is like a large view, yeah? Even if you try to start to find a hook point, it's almost impossible. So we want to move away from that, and we've done in the last, I guess, 10 years. SOA started it. Service-oriented architecture was the first movement that started saying, listen, this is not going to work. The main reason for service-oriented architecture was scale. It wasn't just the monolith was exceeding the how much you can scale up your machines and your networks and disks and all that. Yeah. And now we have this microservices thing, which is service-oriented architecture 2.0 or whatever. Let's not get into that. But those two, so SOA and microservices, are using the same kind of methodology at the bottom, behind everything, the same kind of methodology of analyzing the domain. What we're trying to do is to take this big monolith and build something more modular, more isolated, more encapsulated, and reduce the coupling between the different moving parts. Is that roughly what we're doing? Yeah, we're happy with that definition? And that concept started, again, many years ago. It's not new, and it was introduced by Eric Evans, called domain-driven design. I'm going to borrow that bit, at least the second half of the book, yeah? The stuff that talks about bounded context and domain-driven design, how you build those bounded contexts and how you make the separation or the isolation of, and we start with context. So just a dictionary definition for now. So context is what we have all around something that gives us a better understanding of what the thing is. Okay, so if I just tell you, if I just say, give me an Irish term. Something crack. Excellent. Crack here means, oh, that's a lot of fun, lots of, we're having a good time. In the States, it means crack.
Also having a good time.
Yeah, everyone's having a good time. Without context, we could understand the meaning of something to be very different. Another example would be a user account, right? A user account could be a bank account, could be a checking account, a saving account, and a login account, a some account, whatever account means, if we don't put context around it, we lose the meaning of what we're actually going to do with this thing. And different people might use those different things differently. For example, if you're building, two teams are building a system, and both of them are looking at this account component, and one wants to use it as a commercial account, and the other one wants to use it as a user account, as a, like the same thing. It's still, you can see that it talks about money and it talks about, but the commercial behavior is different to the a private account or personal account. And both are trying to develop this component that they share in order to make it work the way they want it. So, do you think it will work? Possibly not. So, again, context gives you this thing that says this is the information that I need in order to do the job, understand what needs to be done. Boundary is the thing that stops us from killing ourselves, right? We have a boundary on the road, we have a boundary, we have a window here that if we would ignore, we're just going to fall two floors down. Maybe it's not too bad here. It's the thing that we can define and say, this belongs to me. Beyond kind of method, we have to kind of comply with a couple of things. One is the update user thing goes out the window, yeah? Because if we're not explicit about what we want to do, and we don't have enough context, so we don't say, update user phone number, or update customer account, personal account details, or create user address, then we're not gonna get there, yeah, right? Because update user can do 500 things, depending on how much data you put in, and how much business rules we run on top of it, and how many scenarios, how many things, how many matrices in the matrix, how many things are going to make a different decision, okay? 50 things, sorry, 500 is too much. Tend to get carried away. So explicitness is the first step of understanding. Again, in the domain, when you look at the domain, or when you look at the existing domain, a new domain or existing domain, you have to find this explicitness, this context that says, this is what I'm trying to do, and we all agree, this is what he's talking about, the ubiquitous language. We all agree that in the context of the system, a user personal account means an account for a user that is uses, as opposed to a business user, it's a personal user. So the current account is a term in banking. Current account could be for a business user, and current account could be for a private user, right? So saving account, the same thing, investment accounts, and so on. So we all agree that this is what we want to do, and then we go and say, but what do we actually want to do? And we define it as this explicit meaning. It has, it's this action that we're going to do, and whatever is underneath is going to do exactly what we say in the title, yeah? Exactly what it says on the tin. Once we get those functions or those bounded contexts, we can then easily put the boundaries around them. Because first of all, we have the boundary of the bounded context. We say this thing, the user email and password, or the username and password have to be done at the same time, and it's one table, and all the business logic around it is going to be in that component, in that create user account component. Of course I can drag the kitchen sink in, yeah? I could say, oh, but what about address, and what about phone number, and what about his materials, his wedded status, what about his, is he active or not, is he, what about all these other things? And of course we can drag everything in, but if we use the kind of the reduce, kind of map and reduce kind of idea, yeah, where we just go, okay, is that as little as we can go? No, we can go smaller and smaller, and we get to this point where we say we can't reduce anymore. Yeah, this is what we need in order to make this thing work. And the second level, or the second, it's actually part of it is the boundaries. Once we have all these little boundaries, all these bounded contexts, we can now say that everything that has to do with the user is in the blue service, and everything that has to do with the finance is in the red service. Now, on the technical terms, you can argue that the boundaries should also be kept in code, but I would argue that that's not a must. Yeah. So, technically speaking, if I have a user and I have some function that does something in the UI and something in a web service and something in, a Windows service, those three pieces of code could belong in three different solutions that do three different things. But logically, they're all the same thing. Okay, so whenever I ask myself, where does it belong? I say in the blue service. Later you say, oh, the blue service is actually finance. But I'd argue that if you don't determine the name of the service early, you get better at putting things together without, kind of associating them with like, oh, this has to be finance because it's finance. But it might be that, it is very, very hard to do it anyway, so give yourself a break and call the blue service the yellow service. All these things belong together and they live happily together and they're very happy. Encapsulation is again the same. If I have the bounded context, then I can say for sure that this piece of work or this unit of work or this component is going to do what it says on the tin. I don't need to know what it does inside. I actually don't want to know what it does inside because that would cause leakage, right? If I need to know what happens inside that component for it to do its work, it means that I need to start engaging with this component, right? Does that make sense?
Yeah.
If I need to ask that component, hey, can you accept this user? And I get a reply, and then I submit the user, what did I do?
You ask the service how it behaves internally.
Yeah, and I rely on its behavior in order to tell me what to do. And I just created this logical coupling that is never going to go away, yeah? Although it's not physically coupled, it is still, I'm now dependent on this other thing to reply, otherwise I can't do what I want. So I need to know where it is, I need to know what its API looks like, or what kind of messages does it accept, and I need to wait for a reply. And logically I have to have that reply stored or something, do something with it, manage the state, and I'm done. So if that's what we see, it means that we need to go back to the boundaries and probably put those things together, or part of those things together. Does that make sense?
Yeah.
So encapsulation and cohesion, I guess, those two nice words, are, will give you that really solid bounded context where, all the things that's inside will work, do what they say on the tin, and you don't need to worry about leakages and expansions of your code and business logic to the wrong area. So let's walk through a very, very, very optimistic and naive example, and just take it as a small exercise. Okay, we have this coming back to what we saw earlier. We had this lovely table structure, and let's look at each function and what we have there. So the requirement is to create a user login. Okay, so the simple thing that we need here is the email and the password, because without the other will make no sense. There's no, we need to capture those two, we need to verify those two, and so on. We also may have an account verification process. How would you describe that in business logic? In data, from a data structure point of view? Verification process, I mean not validation, I mean verification. So I send you an email and you reply back to the email, and now I know that you actually got my email.
It's an RPC call. RPC call?
Yeah, you could do an RPC call, right? A remote procedure call. But is it something we can model as an entity? Can we do it in one bounded context?
Well, you could have an email account verification service.
Okay, you're getting there. What I'm trying to say is that there's a process. Okay? And that's where things get interesting, because if we try to put processes into our kind of bounded contexts, we're going to make them very big, right? Evans describes it differently, but I don't want to kind of compare Evans and this, but there is like a parallel in Evans' definition, and that's kind of the service boundary, yeah? So these are things, the service processes or service policies, these are things that lie just above the bounded contexts, and they orchestrate or choreograph those processes, okay? And if we try and put those processes inside our bounded context, we're going to reintroduce coupling and reintroduce dependencies that are there is almost no way to solve, yeah? Does that make sense? Mm-hmm. So in object-oriented programming, that was totally valid, yeah? We added inside the create user login, a call to validate user email, right? We did, let's say that we could call a web service to validate the user email. We completed that. Those were two separate encapsulated objects. But they had very tight coupling, right? But if we do that in a distributed thing, we have to put them together, right? They have to be together in the same thread, in the same, okay? Are we okay with the process thing?
Yeah.
and then we can ask the question is, then the next question is, where does access control belong?
On the service.
Possibly. But access control, where do we do access control? Where does it happen?
It's a cross-cutting concern. It happens everywhere.
Exactly. So it couldn't be in the login thing bounded context, right? It does kind of, it might be close to it. It might be in its service, yeah? But it's definitely a different concern, a different process. It's, go and create the authorization for this user, what he's allowed to do, what he's not allowed to do, maybe AD, submitting stuff into AD or whatever, depends on your context, yeah? So, that's cool. So, in this create user component, I only have two fields, right? Maybe three. We agree on that? So I have a component, I have like this thing that has an entry method called create user login, very explicit. And it could be even longer. It could be like create personal user login or create shopping cart login or create whatever, okay? But it's not create user, yeah? It's create user login, and it does two things in one transaction, actually in this scenario. And it takes username, email, it takes the username, the email, and the password. So now this long table that we had, the user, you remember? Not in my example, but what you have in your systems or had in Monolith systems, that's now being broken. Now we just cut two fields out of it, put it somewhere. Okay? So let's look at the customer account. We want to create a customer account, right? Which is not the login. This is now the account. This is where I put the, I relate to this user and say what happened in this account. This account might have multiple users. It might be a company account. So it depends, again, in context. So the only thing I want here in the account is the user authentication ID, right? So I want some reference. Yeah? This is not a foreign key. It's a logical foreign key, yeah? And I'll show you later in the actual tables. Do we need the first name and last name in the account? To create it, okay? Just remember, yeah? We're creating, we're not reading and all that. Leave that for later. This is all about the state changing operations, okay?
No, you can create it with just the user authentication ID, and you can have entirely separate operations or actions later on to update those together or individually.
Yeah. Anybody disagree? Challenge me, come on. It's boring. The important thing is that we want to make the account maybe this not active until we finish doing other things, right? So the account active is really important for us. So now I reduce the account, which usually looks like a, I don't know, 20 fields in an entity with one single ID, into 2 fields. Okay? Again, this is, you know, it's, I'm going really light on the details here, okay? But it's to make the point. So now we look at create contact details, right? It's something that we need to do once we add a user. He puts in his address, his phone number, emails, and so on. And contact, now we have a little bit of more interest, and things are becoming just a little bit less clear, yeah? We have the contact email. Are we going to use the login email? I don't know. Yeah, maybe better not, because that would create a really tight coupling between the login and the communication with the customer, right? What if he changes he wants 5 emails to be, whatever. So, and contact phone number, that could be optional, right? Because some business requirements don't require a phone number. Home address. Would we keep the home address here?
Should be something.
Could be a different component, or could be the same. It's like, again, and refactoring is still an option. And you'll never get it right the first time, so. Obviously, in a real example, that would be a lot harder to kind of figure out which, what, whatever. And, again, I've pointed out that we have this email validation process, right? If you accept this address, this contact email as a validation email, right? We will have to probably do this email validation just to make sure that he actually has access to this email and we're okay to contact him, and maybe there could be many, many more things like that, processes that are around him accepting terms and conditions and all kind of things like that. Make sense?
Can you pause for a second in there?
Yeah.
So are you actually saying that each of these are individual units of work, possible individual units of work?
Absolutely.
Then I'm going to throw in a question from real life, and it doesn't need to be answered now. Maybe you have the answer at the end of the deck or something further down the line, right? So if you could go a little bit back to the other side, like I would assume that each of the individual elements would be a different call to a different unit of work, and somebody will need to make that call.
Yeah.
The email validation process is if you're looking at traditional style of having a UI updating in sequence or not in sequence, all these elements, and then the UI calling the email validation process, or one of your other units of work triggering the email validation process, then the email validation process would be a call to a call. So
It would be
a call to a third party thing, to a remote
absolutely.
thing.
It would be a let's call it a long-running process.
Long running process. So at the end of the day, it's one of my personal interests. If you could go ahead and answer who's orchestrating everything. So it's not a particular question for this moment, but just...
So I'll talk about it a little bit later when we compose everything into the UI and all that, then things become really interesting because it becomes a big mess, right?
Yeah.
And things like that come into question, like what do we do and where do we start and so on. Yeah. So in this scenario, by the way, that would probably be an event or a command that would be raised from that bounded context, yeah? So I created the user contact details, and as a response to that, I will send a message or I will publish an event saying, hey, I need email validation for this contact, okay? And in this event, I put the contact ID, the customer ID, yeah? Or the address ID or whatever it is, again, obviously that could be 5 different components, and that would work asynchronous in the background. What will you do? It will send an email to yourself, you will click a link, you will go to the link on the UI will send a message back to that component, the component will register that you had that you had validated your email, and will publish an event. And now this component, or a friend of this component, so in the same kind of largely bounded code with the same boundary, will add that this validation was done. Okay, it's a long-running process, but it's orchestrated, and this is something that we'll talk more about when we talk about processes. Okay, but good point. So, and it goes on and on. Okay, so we do the same with payment details, and when we start with payment methods, and how do we add payment methods, and how do we validate them, and do we add addresses to those payment methods, and shipping is, and shall I go on? It's like all these little things that we need to build and build and build. And again, we look, every time we start thinking that we have this bounded context perfect, we realize we have a process in place, right? So the process thing is going to nag us and continue along the way. This is something basic that we have to have. Otherwise, those beautiful, isolated, well-defined, bounded contexts are not going to work. And, as Eric Evans said, it's not going to be perfect, yeah? So just don't, give yourself a break. Yep.
Is that a deliberate typo?
No.
Oh, it's not going to perfect.
Well, it's not going to perfect either. Thank you. I'll fix it. No, it's not.
Keep it.
Yeah.
Next
So
time you present, you say, did anyone notice?
I'm not that. So it's not going to be perfect, and it's not going to be perfect because it's these things are trial and error again and again and again, and it will never be perfect because unless you finish the project. Have anybody here finished the system any times lately? Hopefully not, because that means you're fired, right? Business just, yeah. So this is going to change all the time, and it's really, really hard. So just accept it, that it's imperfect, and try and keep those things, just refactor and make it better all the time.
Is this the main criteria though? Like, what's the smallest unit of work? Do you not consider because if you keep going and if you have like a very small system with 50 tables and you keep throwing 3 or 4 fields here and there, it's going to be a goddamn explosion at the end.
Very good.
Do you not consider what gets maintained by which team? Potentially a couple of those user concerns are in this room only, and what's
my next slide?
Yeah, what needs to be deployed together? And
Absolutely.
oh,
So this is the next slides, or a couple of slides later.
okay.
The question was, do we not care about actually how is this thing going to be deployed and run and maintained and all that? Obviously, this leads to loads of little components that are in isolation of each other, that have a dependency, obviously. Yeah, we need to do things together, but they're all little isolated things. We have a very high ramp up, yeah, to build something like that, because we're looking at loads of things that need to be separated and communicate, and messages that are flying around, and databases and tables and teams that who owns what and all that, right? So yeah, that was the question. We'll talk about it later. Coming back to the not perfect thing, again, accept that you're most likely will not get it right, not in the first time. And as you go along, you'll see what you learn from your mistakes, and you continuously have to be pragmatic, yeah, and understand all your limitations or all your context, and do your best to deliver. Okay, so don't, gold plating this is going to be extremely painful, because as soon as you finish gold plating it, somebody will drop a a little acid on top of that, yeah? And say, oh, but just one thing, I wanted this to do like that. And you go, So this, as you said, times 500 is what we're going to end up with, yeah? Or times 50. This is the yellow service, the orange, the green service. These are the logical boundaries, not the actual components, okay? And each one of them, we probably have tens of components. It doesn't mean that they have to run in different processes. It doesn't mean they have, you can put all this in a single monolith app and run it, yeah? There's nothing, as long as you don't need to scale, there's nothing that makes it not work. Only people, yeah? Only the fact that you need this piece of code, this stuff needs to be managed by one team and deployed on this server, and this piece of code needs to be maintained by another team. If you put everything together in one process, in one repository, I don't know, I've seen projects that have more than 200 developers, let's say, and they're all trying to update the same repository, right? Do you like to do that? Yeah?
No, it's horrible.
What do? You sit and wait till you get a window. You try and push. Oh, it fails. You get latest. You try and push again. Then what do? Force push, right? I need to go home. And then everything blows up, right? So these things, of course, and I'm mentioning it later, that these things are considerations you need to really live with, yeah? But just as a simplified kind of diagram, that's what we're going to end up with, okay? And this is what our table's kind of going to look like. And this is not big enough, is it? Anyway, I try to kind of illustrate that, we have some properties on those tables, some fields that are only IDs, yeah? They're IDs that reference each other. If I have a user account, the user account will have the authentication GUID of the user, and I'll have something else, the same for the contact details. I have loads of IDs here. I only have the email as actually a value type, yeah? But the rest is all references from other entities in my thing. And I try to color it, so all the purple stuff belongs together and all the green stuff belongs together, but there is only one owner of that color, okay? Does that make sense? So the customer account ID, it is owned by the account service or the account boundary, okay? And it's the only one that actually creates it. All the rest are reading it, okay? And notice that there's no foreign keys here, okay? So align that with those services, and this is going to be, I tried, by the way, and I will do it better next time, I tried to color the different tables to kind of match them to the services, or to the boundaries, I guess. But basically, all the customer stuff, the customer contact stuff is going to be in one thing, and the login stuff, the authentication is going to be in one thing, and the payment stuff is also going to be probably in one boundary, okay? One thing that lies together. Does that make sense? Does that, any of you are, obviously you're doing microservices, you know this, right? You have this kind of fragmented tables that have very little in the matter of entity, but they're, yeah? Or you still do the microservices on top of a monolith? Anybody does here microservices on top of a relational database?
Yeah.
Okay. That's the three mistakes in messaging, and I've done it myself, so I can't, I was the first one to do it. Oh, that was the first thing I did with messaging, and that was like to build a whole messaging system, a whole beautifully architected messaging system that ran on top of a relational database, right? Can you imagine how nice that was, yeah? That was fun.
Why not use event sourcing?
What?
Why not use event sourcing? Just emit events and forget. Like, don't store this.
We're not talking about the technique at the moment. This is about how you decompose stuff, yeah? Yeah? There's all kind of ways to do it, yeah? But the point is that, you know, once you introduce coupling and messaging, you're back in square one. You just made yourself a huge system that's going to be slow because it has messaging in the middle, and it's going to become a big ball of mud distributed, right? When something fails, you'll have to look in 500 servers to figure out which one failed. Instead of just going to the one server going, oh, SQL went down. Restart, end of story. You know, SQL's struggling, I'll add another CPU, whatever. Okay? And coming back to your question earlier, you've thrown me around a little bit. I shouldn't be answering questions probably. Find the bounded context and work your way up. So instead of going from the database up, find the bounded context, build your components, and work yourself up, your way up, and join the things. I'm not saying put the code together and all that. I'm just saying put the things that are in the same boundary together and associate them with each other, just logically, yeah, not physically. And that they would kind of become your service, if you wish, okay? Now this is a bit orthogonal to microservices, right? You all agree? Disagree?
You can build your microservice around your domain. So
You could, yeah.
Microservice that reflects your domain.
Okay. So I think I'm not an expert of microservices. I'm not the first one who did microservices. But I'd say that most microservice people are kind of taking a bunch of stuff and just putting them in a process, right? And making that a service, and that is the end of the boundary, if you wish, yeah? And there comes then the questions start about how do you process stuff, right? How do you put everything together? How do you orchestrate it? Who owns the UI? All those things, yeah? Sound familiar? Mm-hmm. Awesome. So I'm borrowing from service-oriented architecture, and I think that it's good to learn from everyone, yeah? So my experience comes from service-oriented architecture, and the service boundary or the grouping or the bounded context what does Evans call it? Forgot. Service, he calls this something, I'm sorry I forgot the name, but it is the kind of the service context, if you wish, or it's bigger than the bounded context basically, okay? So if you find that service boundary, it's easier to then go and say all these things belong together logically. Don't put, if you need to do something to the user when you're doing something to the financial thing, don't do it there. Send a message over to the financial thing and he'll do it.
That's like an application service, though. It's not like you have your application service, which is your interface into your context.
Yeah, but the idea is just to keep it logically and not physically. That's the hardest thing, because when we talk about services, it's an overloaded thing, right? What is a service? Calculator? A Windows service? A web service?
Yeah, all of the above.
All of the above?
Yeah.
A washing machine?
Yeah.
Yeah, to me,
Essentially,
service is a piece of code that doesn't fit into an entity.
But that's where, so but that's good. That's the right. So if you take a couple of bounded contexts and say all of them belong together, and they could be decoupled, yeah? It makes no sense to take those bounded contexts and say, oh, this one's going to run over there, this one's going to run over there, and now we're going to have an overhead of chitty-chatty things instead of just them being together and being close to each other and kind of knowing, they're friends, they're not enemies, yeah? But they know each other, they're the same boundary, they're in the same courtyard, they play together, yeah? They play nicely together. And instead of just going like, no, we have to cut everything, and cut, and then you end up with loads of little things that mean nothing, and they're all over the shop, and you're trying to figure out how to orchestrate all that. Yeah? So that's what I'm trying to kind of push for. So outside the boundary, you're going to have loose coupling, and I'm referring to messaging and stuff like that here. Yeah. Okay. So outside the boundary of this the service or the group of bounded context, you're going to have loose coupling, which means that you don't expect any kind of RPC. You don't expect for state changing operation. We're not doing request response. Okay. We're not allowed to do request response because that means that you're trying to do something to someone else, right? And that breaks the whole idea of distributing stuff, right? Inside the boundary, tight coupling is not a problem. Yeah? So inside the boundary, if you're doing 5 things in a procedural manner, it's totally fine. There's nothing wrong with that because you expect this kind of behavior, right? Obviously, you have to be aware of not growing that bounded context to be a whole application, right? So, we have to kind of, and another one is probably the respect the single data ownership, yeah? So if there is a user table in my, this login table, authentication table in my domain, in my system, there's only one component, logical, I'm not saying if you scale it out and there's 10,000 of them, but one logical component that can update this table. All the rest can read, whether it's from its table, now that's a whole different argument, or from a view model, or from can read from a cache, or have a copy of the data, it doesn't matter. But they're not allowed, all the rest of the components in the system are not allowed to modify this data.
It's like an aggregate root, is it?
Exactly, bounded content, yeah. Sorry, I didn't mention aggregate root. That's a good point, because that's part of the idea here, okay? So, only one thing in the system owns this one piece of data, and it's really, really important, because, again, once you have multiple components trying to access, multiple bounded contexts trying to access the same piece of data, what happens?
Race conditions.
Race conditions, we're going to be, one. Yeah, and back to coupling, right? Back to the thing that we have like 2 things trying to access the same thing, one in one context and another in another context. Remember the context thing? And now they're both trying to access the same thing, but for 2 different reasons. One is trying to update the user because it's trying to update the address, and the other one is trying to add some financial details, right? And if they're both...
Sorry.
Yeah.
So all communication goes through that route, basically.
Yes.
If you have
So again, we need to be really careful about the definition here because the important thing is the state change. Okay.
Okay. All updates. So if you have an aggregate route that has multiple aggregates inside it, other entities, if you're going to update that small entity over here, you have to sort of pass the aggregate root entity with, say it's a site with a list of site users. You want to update one site user, you push the site up with the site users list one added to it. Yeah?
But again, you're implying a little bit that there is like a dependency chain in the database and all that.
Yeah,
I don't agree to that. So I didn't say that. Okay.
Yeah.
That it's the bounded context. It's this thing that needs to work all together, okay? It could be a bounded context by process, okay? So I have to, as you said, update the site, create a record, update the site, and do another thing, yeah? And all these things have to happen in one go, right? So they have to belong together, okay? And then when they belong together, whether you do DDD style aggregate roots, dependency graphs, and all that, that's your problem. I won't do it because then those dependency graphs are tightly coupled in such way that you almost it's a lot harder to change. But that's different. A whole if you put all this bounded context in one component and you make sure that the process updates it in a a transactional way, okay? So not ACID transaction, but that all of these actions happen, and then you're done, right? And you know when your state is done, then you're good, right? Whether it's a single thread or multi-threads or single message, multiple messages, doesn't really. But the important thing, I think you got the important thing, yeah? The important thing is that you don't try to extract this to other things, and that there's only, one way in, yeah? One
door in.
one
door
thing
in.
that is responsible for that state change. Because otherwise you lose, once you lose that responsibility, everything's out the window, right? Because if you can do it, I can do it. If I can do it, you can do it. If you can do it, you can do it. And then we all do it together, different contexts, and we're all trying to do different things on the same thing, right? Now, if it's all, you could get away with it probably if every context has a different role, so it's a it's not the same user, then maybe you can get away with it. But still, logically, once things change, you're going to break something. Yeah. Remember, just 1 second. Remember that this is about data writes. Okay, this is about state changes. The reads are a totally different story. Okay.
Regarding the data rights, I just want to confirm for the first point, because it's very important. If updating yourself, you need to update something out of the context. You're saying never do a blocking call, throw a message instead.
Exactly.
Okay.
So in between your components, in between your running processes, actually, things that don't belong in the same app domain, you're going to send a message. You're not going to be calling another app domain. You're not going to be calling an API. Now this, again, in the context of single responsibility in data in the domain. If you're talking about accessing a web service in order to get to make a payment, that's a totally different story. It's a technical component. It's outside the boundary of that, the logical boundary thing, and we need to look at that totally different, okay? So now, this is where everything starts to be really fun, right? We have this distributed thing, and it's running on 3 processes, okay? 5 processes, sorry. I've dropped all the zeros in order to make it simple. And we're trying to build all those composition points on top of it, right? And now things are getting really, really shitty, because we have a UI, and the UI, most of the UIs, are composites, right? There's a little bit of shipping, there's a little bit of sales, a little bit of marketing, a little bit of branding, there's a little bit of the user data, there's a little bit, yeah? Make sense? Mm-hmm. And we need to kind of compose all this sea of stuff onto the UI in the right order and make sure that everything's aligned and all that. And that's where things get really, really tricky. And I don't have good news, like I don't have like Jack in the Hat solution for that thing. But you have to acknowledge that it is a composition. That's the first step, right? So don't think of the UI as a monolith, right? It's not a one view that's going to do everything for you. And the other thing is that composition means that you need to pick up stuff that you logically know what each UI element belongs to. Logically, okay? So if I have a login thing, that logically belongs to my authentication service, right? Logically. It runs on a different process, it's on the other side of the world, it's distributed on hundreds of servers, right? It's nothing to do with it doesn't have any direct connection to my, physically, to my authentication service, right? It only is logically that little bit. Obviously, in the UI, you'll have to publish events, right? So you're all Java something? JavaScript something? No?
Angular.
Yeah.
Ember.
Ember. Anybody here like me that doesn't know all those frameworks?
Try to steer clear of them, but have to unfortunately.
So- Obviously, all those tools and the new frameworks and the old frameworks all do those kind of things. Yeah, in Angular you can you create your own little bus in the front end and get events back and forth between the front end and back end. And obviously, to get good UI composition, most of the time, what you're gonna do?
Our UX guy.
He knows.
Pass it off.
Most of the time, you're gonna read, right? Most of the time, you're gonna display data, and then from time to time, you're gonna submit data. So the reading thing comes back to, or goes into the whole read model idea and getting data out there, aggregating it, or slicing it, dicing it, making it available so that consumers and composition clients, like an API or UI, or maybe your integration endpoints, yeah? So customers that want to use you as a white label or whatever, they all use those, they need data composition, right? They need to be able to go, give me the list of all my users, I want to check before I send a message to create a user, to create a new login, I want to check that this user doesn't exist in the database, right? So I have two options. Anybody care to do the first one? 2 is not. 20 options, but 2 styles.
The create user checks for the.
So the UI will call the endpoint, yeah, and will.
Refresh join.
Okay, so the UI is going to call the service that owns the user table, right? Do a request to that thing, get back the list of users, right? Yeah, it's fair. It's doable, right? It's
True or false.
yeah, and do the validation and all that, right? And then when he's happy that there's no user like that, he'd send a message, right? What's wrong with that picture?
That's right.
You're doing request response from the UI to a backend service that lies somewhere in the ether, 1 of 500 or 1 of 1,000 or 1 of 50, yeah? And now your admin just moved the service, right? And changed the database to be on that over there instead of there. Is that going to be a problem?
Yeah, potentially, yeah.
Yeah? Is that like, it's like crossing loads of networks and loads of load balancers and stuff in order to get the data that's technically yours to read, right? So in that kind of scenario, a better and more proactive kind of way to deal with it would be to create a view model or a read view model or some cache, if you want. I think cache is the closest thing to people get it a lot better than the concept of view models. But it's this thing that when I create a user, I'm going to write to it, or I'm going to send a message to get somebody to write to it, or somebody is going to, some component is going to listen to events that come out of my component that does the work, right? And knows for sure that from a business perspective, this is done. This user is now authenticated, yeah, or being registered. And I'm going to write to this view model. And this view model could be a cache, a Redis thing, whatever you want. This thing distributed all over the world. And all I need to do as a client is go and say, oh, is this user, do I have this user? Yeah or nay? If it's okay, I'm going to chance it. I'm going to chance it with pretty good, I know that, I'm pretty sure that there's no user like that in the system, and I'll send a message over to the backend to submit that thing. Does that make sense?
Can I just clarify that? So you're sort of suggesting that the view models are a stage, client-side stage. So you go to your
Well,
client-side
yeah,
stage
they're kind of
first.
shared state, if you wish, not client-side.
Okay, so shared state. And that system front of the back end. So you go to this shared state first before you then go to the back end.
Well, you don't go to the back end because, again, what we're talking about is like things that are done asynchronously using messaging. So there's no.
Okay, so at some stage
You will call
the
an
back end
API.
syncs up with this shared state by pushing perhaps or by.
It really just
asynchronously
reads,
bringing
yeah.
it back. Yeah, so it's kind of like it sits there in between.
It's like an in-between thing, but I'd like to see it more as this is like the view of the system for the rest of the world, yeah? And even not the rest of the world, it's even for the system itself. But it's the real state. In the old days, we had OLTP, right? And we had the reporting database. Anybody build systems like that?
Yeah, unfortunately.
Unfortunately, we did. But it was actually very good practice because the business never asked to go into our transactional database and poke around and ask for all kind of weird stuff or run queries that the sales guys were trying to figure out, or the analysts were trying to run all kind of really crazy queries on top of our transaction database and lock tables and rows and all these things. That wasn't a problem, right? We could in our reporting database they could do whatever they want. Yes, the data was stale, but who cares? Is it important? It's not. Okay? So view modules are a little better than that because you actually push the state that is logically transactional correct. Yeah? Because what happens in the queues and what happens in the temporary, things in flight shouldn't be a real state. It's not real state. Like, any of you hook into SQL logging thing to do stuff? The SQL log? No? You did.
What do you mean, Sean?
SQL, when it writes transactions, it's called the transaction log, right?
Different log itself, yeah.
Yeah, so this thing, you can hook up into it and get the transactions, right?
That's how you used to have active or active passive.
Yeah, active passive, you have backups, where you can do all kind of funky stuff, right? But you won't do it in a traditional system, right? Not for state to get real state, right? Would you?
In the old days, do a differential way too.
Just give a few Cassandra instances.
Of course, as developers, we can do everything, right? That's our job. We can hack it away. But the problem of reading from the transactional log is that you are reading state in transit, right? You are reading things. It hasn't really got to the disk yet, right? It hasn't. This is what SQL pushes downstream to get to the disk, right? What is really, really, really the state is what's on the disk. Do we agree?
Or is it what's on? I'm not sure. That's persistence. The thing that goes on to this is just persistence.
But this is the real state. Because if the thread dies,
if you're in a system that has latency,
yeah,
your state is what's in front of the user, or what.
Correct. But
Which is not necessarily what's on the disk.
exactly. But this is the discrepancy between how we interpret it and how we actually do it, right? Because if we show the user that his balance is like €1,000, and in the bank right now there's something running in the background that's 3 weeks old that just took 500 off his account, it is actually minus 400, and he's taken another 100 out because he thought he has 100,000 in, or do the maths better than me, then it's like, then we're actually cheating the user, right? But we are transactionally correct because I showed you exactly what I read from the disk right now. So this is the whole, we're getting into the whole eventual consistency thing and all that. So, but it is important to acknowledge it and to put the things together in order to show a state that is acceptable for you, for your business, So if you're real-time, if you're dealing with